Okay, this is Mr. Martin. These are the notes for Geometry Honors, section 6.1. So in this section, we're going to be doing a lot of the same things that we've done already, except we're going to be doing them in 3 dimensions. Um, so we're going to be talking about a lot about planes and space, and how lines relate to them, and properties relating to lines and planes, and um, multiple planes. So if you have trouble with this, these concepts and visualizing, make sure you come in and get some extra help. So section 6.1, the first thing we want to talk about is a definition. We're going to be talking about the foot of a line. So the point of intersection of a line and a plane is called the foot of the line. So normally we represent a plane by just drawing like a parallelogram shape. And we'll give it, usually a lowercase letter, so I'll call this plane M. And then if I draw a line and it intersects it, this point right here, and then I'm going to show that it's dotted to show it's behind, and then solid to continue. So here I have a line going through the plane. I'll call this point A, and we would say that A is the foot of the line. Okay, so just a little vocabulary. We'll be talking about the foot of a line quite often. It's important that you know how to, or know what it is. So moving on to planes and the ways to determine them. There are 4 ways to determine a plane. And when we say a plane, what I like to think about is if you were going to build a table, and what could you use for the legs. So you're going to have this large sheet of wood that's going to be the top of the table. That's our plane. And we want to build a table out of it so that it doesn't fall over. So our first way, it's a postulate. If 3 points are non-collinear, then they determine a plane. So here's our points in the diagram here, A, B, and C, and you notice we can put our sheet of wood right on top of it. 1 point here, 1 point here, 1 point here. So 3 non-collinear points. So think about how this would change if we did make the points collinear, and how it wouldn't really work. Maybe next time you see me in class, you can let me know what you think about that. So the second way to determine a plane is if we have a line and a point not on the line. So again, if you take a look at this first diagram here, we've got our line, which is the sawhorse here, and then again this stick, which would be our point, and we could crudely make a tabletop. Obviously you wouldn't want to lean on the corners over here and over here because it would probably tip over. But you could make a crude table out of it. So second method, a line and a point not on the line. Third method, we've got 2 intersecting lines. They determine a plane. So you can see again in the picture, a fancier table, probably pretty sturdy. And then the fourth way, if 2 parallel lines determine a plane. So we've got our line here and our line over here. They determine a plane as well. So very important that you understand the 4 ways to determine a plane. So you will be tested on these 4 ways. Basically understand them. If you need to, memorize them, but hopefully they sort of are logical and make sense to you. And again, if you have any kind of trouble with this, just come see me for help, or go to the point, or ask one of your friends. And then we're going to need to use these in proofs. Use these in proofs when you need to prove you have a plane, because sometimes you need to prove that things are on the same plane, and you need to prove that you first have a plane, so you use one of these 4 methods here. Alright, so 2 postulates concerning lines and planes. First one, if a line and a plane not containing the line intersect, then the intersection is exactly 1 point. Okay, and we already talked about what that point is called. That point here is called the foot. Okay, so think about your plane as maybe a table, and your line is maybe a meter stick. If you lie the meter stick down on the table, it would be contained by the plane, but if you hold it up so that one end or the other is only touching the table, then you would have a line intersecting the plane again at one point only. And then if two planes intersect, then their intersection is exactly one line. So again, here's our picture. We've got two planes that are intersecting. We can see the intersection is line AB. Think about taking a sheet of paper and just folding it along a straight line anywhere. You would end up with two planes, and that fold there really would be that intersection, and it would be a line. So really that's it for section 6.1. Again, if you're having trouble visualizing the different three-dimensional pictures or have any questions at all, make sure that you ask me, and we'll see you next time.